Can you easily diagnose intermittent SCADA system problems? Have you ever wondered how easy it is to diagnose intermittent problems in supervisory control and data acquisition systems? If you have, you're not alone. This is a common challenge in the field of electrical engineering. Intermittent faults can be tricky because they don't always show up when you want them to. They can occur randomly, making them hard to catch during regular checks. SCADA systems are essential for monitoring and controlling industrial processes. They rely on sensors, actuators, communication networks, and controllers. When something goes wrong, it could be due to a faulty sensor, a glitch in communication, or even a software error. Programmable logic controllers and remote terminal units can also be sources of these intermittent issues. One reason diagnosing these problems is tough is the nature of intermittent faults. They don't produce consistent error signals. Instead, they may happen under specific conditions that are hard to replicate. This randomness makes it difficult to capture them during routine monitoring. Traditional monitoring methods often fall short. Many SCADA systems depend on alarms triggered by events or periodic checks of sensor data. If a fault doesn't trigger an alarm or happens between checks, it can easily be overlooked. Some communication protocols, like Modbus, may not provide timestamp data, which can further complicate things. To tackle this challenge, electrical engineers often turn to advanced data analysis techniques. Anomaly detection algorithms and machine learning can help identify patterns in data that might indicate a fault. These methods look for subtle changes in time series data that don't generate clear alarms. Another approach is to use analog sensors instead of digital ones. Analog sensors can provide continuous data, which helps in spotting abnormalities that digital sensors might miss. Integrating multiple data sources, like Internet of Things devices or event logs, can also improve the chances of catching these intermittent faults. Network issues can also play a role. Problems like latency or packet loss can lead to intermittent communication failures. Some SCADA systems use timestamped data and redundancy to help with this, but diagnosing faults often requires a detailed analysis of the network. When troubleshooting, there are practical steps you can take. It often starts with remote access to SCADA servers, historians, and programmable logic controllers to review logs and alarms. Power cycling or resetting equipment can help rule out temporary hardware faults. It's also helpful to correlate alarms with process conditions and network events. Condition-based monitoring techniques, such as vibration analysis or oil particle analysis, can provide additional insights into mechanical components linked to the SCADA system. Consulting with domain experts can also be beneficial when interpreting data from low-participation nodes in the network. In summary, diagnosing intermittent SCADA system problems is not straightforward. The sporadic nature of these faults and the complexity of SCADA architectures make it a challenging task. However, by using enhanced data acquisition methods, machine learning, and thorough network analysis, you can improve your chances of identifying and resolving these issues. It may take specialized tools and expertise, but with persistence, you can tackle these intermittent problems effectively.